In this video, we're going to take a look at exam revision for fractional and negative indices. So all we're going to do here is run through some exam style questions for fractional and negative indices. You don't really need an introduction or anything like that. Let's get started with question 1. We've got two parts here, part A and part B. So we want to write down the value of 144 to the power of a half. So 144 to the power of a half. So for a fractional power like this, remember the denominator here, that tells us what root we're taking of our base here. That means we're taking the second root, or in other words, the square root here of 144. The square root of 144. And then the numerator here tells us what power we raise that to. Okay, we've got the square root of 144 here, and we raise that all to the power of 1. Remember, if you raise it to the power of 1, it'll just give you the same result. Okay. In other words, we're just simply looking here for the square root of 144. And the square root of 144 here is simply 12. Okay, so we get 12 there. And there we have it. So that's the solution to A. And for B then, we've got a negative power now. We've got a 5 to the power of minus 3 here. So what I do to begin with here, for a negative power, is underneath my base here, I write a denominator of 1. Okay, what I'm going to do here now is take the reciprocal. So I'm going to flip this here and get 1 over 5, and then we turn the power here to positive. I'll take the power here from negative to positive. That becomes 5 to the power of positive 3 there. And then what we need to do here is evaluate this power. So 5 to the power of 3, put that over here, 5 cubed. That's going to be 5 times 5 times 5 again. You might know that kind of just by memory, which in that case would give you 125. But obviously 5 times 5, 5 squared is 25, times that by 5 again, you get 125 as well. Okay, so in that case then, 1 over 5 cubed is 1 over 125 there. Okay, so that's the solution to A, that's the solution to B, and that gives us the solution there to question 1. Moving on to question 2 now. Again, looks pretty similar, so we're asked to write down the value. And again, we've got two parts here. So for part A, we've got 2 to the power of minus 3. So again, we've got a negative power here. So what I do to begin with, I place my denominator here of 1. We then take the reciprocal here. So in other words, we just flip this fraction. I'll write this now as 1 over 2. And then we make the power here positive. Be 2 to the power of 3. Well, 2 cubed, that's 2 times 2 times 2. That will give us 8. What we get here then is 1 over 8 there. Okay, so that's the solution to A. Moving on to B now. I've got 16 here. So 16 to the power of 3 over 2. So 16 to the power of 3 over 2. So remember, for a fractional power like this, the denominator tells us what root we take here for our base. We're taking the second root here, or in other words, the square root of 16. We take the square root of 16. And then my numerator here of my fractional power is what we raise this result to. Okay, so we're going to cube this result here. That's the fractional power here, or my numerator here to my fractional power. So in that case then, the square root of 16 is 4. What I get here then is 4 cubed, and 4 cubed is 4 times 4 times 4. That would give us 64 there. Okay, and there we have it. So that's the solution to A, that's the solution to B, and that gives us the solution to question 2. So if we take a look now at question 3 here, again we've got two parts. So for part A, we just want to write down the value of 25 over 16 to the power of a half. Let's just write that down here. We've got 25 over 16. Like we said, that's to the power of a half here. So here we've got a fractional power. Now, in this case here, when we've got a fractional base like this, we've got 25 over 16, the power of a fractional power here like this. And what I'm going to do here is technically think about this in two parts. So what I've got here is the numerator. So my numerator here to this power will be divided now by this denominator here, this power as well. So we're just splitting it up now separately. Okay, so rather than having this full fraction to this power, I can write this here as 25 to the power of a half. then we divide that here by my denominator here to this power as well. So it's going to be 16 to the power of a half. Okay. So from here then, just apply our rules now for fractional powers. So the denominator here tells us what root we're taking. I'm taking the second root or the square root here of our base. So that's going to be the second root or the square root 25. And then the numerator here, which is 1, tells us what we raise all of this to. But obviously if it's just 1, then it doesn't affect our answer. Okay, so it's just going to be the square root of 25 over the square root here of 16. It's 16 to the power of a half. It's going to be the square root of 16. So now all we need to do here is evaluate each one of these separately. So the square root of 25 would be 5. And the square root here is 16, that would be 4. In that case then, the value here of 25 over 16 to the power of a half would be 5 over 4 there. Okay, so that's the solution to A. We move on to B now. I've got 2 over 3 to the power of minus 2. So 2 over 3 power of minus 2. So again, all I want to do here is just find the value of 2 over 3 to the power of minus 2. So for part B then, we have now a negative power here. So how do we deal with this here? Well, the first thing I'm going to do is get rid of the negative part of my power. And the way that we do that here would be to flip fractions. So when you have a fractional base like this, all you simply need to do then to get rid of the negative power here is just simply flip the fraction. This is the same then as 3 over 2. Then our power here becomes positive. So rather than minus 2, this is now to the power of 2. Okay? And then again, just like we did here for part A, what I'm going to do now is think about this separately. What I've got here now is my numerator to this power divided by my denominator to this power as well. We've got 3 squared over 2 squared. And again, all we need to do here now is just evaluate each one of these separately. So 3 squared, that would be 3 times 3, giving us 9. And 2 squared is 2 times 2, giving us 4 there. So we get 9 over 4. And there we have it. So that's the solution to A, that's the solution to B, and that gives the solution to that question. Moving on to question 4 now, what I've been given here is this equation. So let's just write down the equation here to begin with. We've got 2 to the power of n equal to 1 over 8. And here we're asked to find the value of n. So what I do here to begin with is I just pick a few values of n and just see what happens. Okay. So if I pick n equals 2, for example, then what I'd get here, so do it down here, we'd get 2 squared. That would be 2 times 2, which is 4. Obviously 4 isn't 1 over 8, so n won't be 2 here. Okay. So if I pick n equals 3, for example, we get 2 cubed. So 2 times 2 times 2, that would give us 8. Now obviously what we're looking for here is 1 over 8. We got 8 here. There seems to be some sort of connection, okay? But we want 1 over 8. So you might notice straight away here what you need to do. But if not, what I'd do now is I'd pick smaller values. Okay, because obviously if I keep increasing the value of n here, then this number here, the result that we get, will keep getting larger and larger. Okay? Because obviously we need 1 over 8, so it's going to get smaller and smaller. So for now, let's say that n is 1. We get 2 to the power of 1. That would just simply be 2. It's getting smaller now, so we're going in the right direction. So let's keep going here. 2 to the power of 0. Or remember, anything to the power of 0 is 1. Again, we're getting smaller. We're going in the right direction here. So now we enter the negative powers here. So 2 to the minus 1 then. Or remember, what we do here is we write a denominator of 1. We then flip this here and we make the power positive. This is 1 over 2. Now the power becomes positive here, so we get 1 over 2 to the power of 1, which is simply 1 over 2. Okay? And again, we're going in the right direction. Okay? But do notice here, the 2 to the minus 1, we get 1 over 2, just simply the reciprocal here of our 2 to the 1. Okay? So again, that might hint straight away what you need to do now. If not, let's keep going here. Let's say I've got 2 to the minus 2 here. Well, we write the denominator of 1. We now flip this here and make the power positive. So I'm going to get 1 over 2, make the power positive. Get 1 over 2 squared. 2 squared, that's 2 times 2, which is 4. We get 1 over 4. Okay, and hopefully you notice what's about to happen now. If I keep going here, so I'm going to do 2 to the minus 3. That's going to be 1 over 2 cubed. Don't forget the denominator of 1 here. flip that, and then make the power positive. And then 2 cubed is 2 times 2 times 2 again. And notice we get 8 there. So what I get then is 1 over 8, which is exactly what we needed. So in that case then, n is minus 3. Okay, so therefore, let's do it down here. So therefore, n is equal to minus 3. Okay. Now, you could have saved a bit of time there. Like I said, what you might have hopefully noticed here is because this is 1 over, and it's going to involve a negative power. Okay. So from there, then it's just connecting this base here of 2 to this denominator of 8. Okay, so in that case, if you notice that 2 cubed is 8, that would simply be 2 to the minus 3, giving us 1 over 8. Okay, but there we have it. So that's the solution to question 4. So if we take a look now at question 5 here, starting off with part A, we're asked to find the value of 7 to the minus 2. So 7 to the power of minus 2 here. Because we've got a negative power, the first thing I'm going to do here is write my denominator of 1. Placing the denominator of 1 here. So now what I'm going to do is I'm going to take the reciprocal. So in other words, I'm just going to flip this fraction. Then we turn the power here from negative to positive. So what I'm going to get then, 1 over. We get 7 here, and then like we said, the power now becomes positive rather than negative. We get 1 over 7 squared. And 7 squared is 7 times 7, which would give us 49. So what we get here is 1 over 49. Okay. So there we have it. So that's the solution to A. Moving on to B now. We're given that 10 times the square root of 10 is equal to 10 to the power of n. So let's just write that down here. We've got 10 times the square root of 10. And that's equal to 10 to the power of n. So because we're looking at indices here, obviously we'd expect to be able to use the rule of indices here. And we're times in here, so what I'd expect in a moment is that we might be able to add these powers, okay? So this 10 here, we don't write it, but the power here is a 1. And this square root of 10 here, again, rather than writing this as the square root of 10, what I'm going to do now is write this with indices, so in index notation, okay? So remember the square root of 10, that's the second root here of 10. We don't write the 2, but it's the second root of 10. Then we just simply raise that to the power of 1 here. We don't raise it to anything in particular, so it's just going to be the power of 1. So in that case, then what I'm going to get here is 10 to the power of a half. Now, if you take the square root of a number, so if you've got the square root of a, that is simply a to the power of a half. Okay. So what I've got here then is 10 to the power of 1 times 10 to the power of a half, and that's all equal to 10 to the power of n. Okay, when we simplify this now, that would simply give us n there. Okay, so because the base is the same here, they're both 10. Okay, we can then add the powers here. So when you're multiplying like this, we add the powers. Okay, what I'm going to get then is 10 to the power of 1 plus a half. Okay, remember all you're doing here is adding this integer and this fraction together. So what I've got is 1 plus a half. So obviously when you're adding fractions like this, you need a common denominator. So this one here, we don't write it, but underneath there would simply be a denominator of 1. So 1 over 1 plus 1 over 2. So to add these here, this would need to be a denominator of 2. So that would be 2 over 2 plus 1 over 2. And in that case then, 2 plus 1 is 3. So we get 3 over 2 there. Okay. So our solution here then is going to be 10 power of 3 over 2. And in that case then, because we're simply looking for n here, which is my power, in that case then, we can see that n is 3 over 2 there. Okay. And there we have it. So that's the solution to question 5. So to finish with here, we take a look now at the very last question. Again, we've got 2 parts. Let's begin with part A. So we're asked to find the value of 8 to the power of minus 2 over 3. Let's just write that down to begin with. We've got 8 here to the power minus 2 over 3. So the very first thing that I'm going to do here is deal with the negative part of this power. I'm going to place my denominator of 1 here. Then take the reciprocal here, or in other words, just flip this fraction. And I'm going to get 1 over. We get 8 here. Now the power becomes positive. So rather than minus 2 over 3, you know, we get 2 over 3. 2 over 3 there. So from here now, we now need to deal with the fractional part of this power. So remember, the denominator here tells us what root we're taking. So in that case then, I get 1 over. So because my denominator here is 3, 2 over 3. So in that case then, we take the third root, or the cube root of 8. We take the cube root of 8 here. And then remember, our numerator here tells us what we raise that result to. So because this is 2 now, I square the cube root of 8. Okay, like so. So the cube root of 8 would be 2. We then square that. What I'm going to get here is 1 over 2 squared. And 2 squared is 2 times 2, giving us 4 there. So we get 1 over 4 there. Okay, that's the solution to A. So now let's take a look at B here. We're given that 5 times the cube root of 5 is equal to 5 power of n. And let's find the value of n here. So 5 times the cube root of 5 is equal to 5 power of n. So again, because we're now times in here, and I want to express this here as a single base, with just obviously just my 1 power here, then obviously I'd expect to be able to simplify here. Okay, so this 5, again, we don't write, but that would simply have a power of 1. We've got 5 to the power of 1. This cube root of 5 here, so again, using the rules here of fractional powers. So in this case then, the cube root of 5, well, the root here, that tells us what the denominator is. So our denominator here would be 3, taking the third root or the cube root of 5. And then because we don't raise this to anything here, in that case then my numerator here will simply be 1. Okay, so in that case then what I get here is 5 to the 1 times 5 to the power of a third. And that's going to be equal to 5 to the power of n. Okay. So now because we're times in here and we have the same base, we can simply add powers together. I'm going to get 5 to the power of 1 plus a third. So 1 plus a third here. Again, to add this whole number, this integer and this fraction together, then this whole number here would need to have a common denominator with this 3 here. So this is 1 over 1. But to add these here, like we said, this denominator must be 3. That would be 3 over 3 plus 1 over 3. And in that case, then what I'm going to get here is 3 plus 1, giving us 4. And that'll be over 3. Okay. In that case, then what I get here is 5 to the power of 4 over 3. Remember, what we're looking for here is n, which is this power. So therefore, n is equal to 4 over 3. Okay. And there we have it. So that's the solution to B. And that gives the solution to the very last question there, and brings the end of this video on exam revision for negative or fractional and negative indices. So in the next video, what we're going to do is we're going to take a look at an introduction to the product rule for counting.